This video is sponsored by PCBWay. Hello everyone. Today I've got a very special video and a small announcement. Some of you already know this, but I've been a part of the Prominence One team, which actively works on 2 new VR headsets with slam and full facial tracking. Today I will show you the latest Andromeda controller Devkit, which is in a bit of rough shape right now, but when it's finished, it will have a real inside-out tracking, index-style face buttons, and of course a proper finger tracking. Everything will be SteamVR compatible, and we aim to make almost everything open source when it's finished. Anyway, that's all for the announcement. Let's get right into the video. I start the project the same way as I always do, by ordering the PCBs from the PCBWay, sponsor of this video. This time I will be using only one custom PCB. It's a 4-layer board with ESP microcontroller and, as you will see in a minute, a beautiful matte black solder mask. This time I've ordered only 5 pieces, since this design will have to be changed in the future. As you can see here, the boards look absolutely stunning and all of the traces are made with the highest precision. Just like always, I will solder the boards myself using my old hot air station. I will cover the whole board with flags, which will make applying solder way easier and will minimize the risk of getting the cold joints. And now I will cover all of the solder pads with solder. I don't really use any stencils, since most of my boards are pretty small and I can easily do this by hand. I usually transfer all of the parts from one board to another, but this time I will be getting my parts from this Ziploc bag. I can already tell it will be super fun to do it this way. I've soldered the microcontroller parts first, since most of them can be soldered with hot air. All of the faceplate buttons, as well as the joystick, will be mounted on the other side. For the faceplate buttons, I will be using the 4x4 tact switch buttons, which are super cheap and great for prototyping. I've had to solder the tact switch buttons with regular soldering iron, since I can easily melt them with hot air. So now let's continue and solder the joystick. I've decided to use the Nintendo Switch one, since I've already had a couple of them at home, but for the future versions I will use a Hall effect one. As you can see here, I've got a joystick version that has regular pins instead of the FFC cable. I will use this one instead of the FFC, since it's a bit easier to install. And here is the joystick after soldering, but there is still one more component left to solder, and that would be the RGB LED for the status indication. You can see the pins for the LED right here. For the initial version, I've decided to go with the through-hole LED, since it will be way easier to debug, but the future iterations will use a proper SMD component. Of course, I've had to shorten the LED pins, since those were way too long. As you can see, after soldering, there's a lot of flux residue. This doesn't look good at all, so let's clean it first before continuing. In order to clean my board, I will use the special flux remover and a regular toothbrush. Alright, let's connect the board to the PC and check if everything's working. I've uploaded the Hades VR controller firmware, and as you can see, the status LED is now blinking. This means that the radio chip is not connected. For the radio chip, I will use the regular NRF24L01, which I've used many times before in my previous controller builds. Of course, the ESP has built-in wireless communication, but the proper firmware is not finished yet. But first, let's install the lower mainboard housing. This is the main controller piece, which houses the PCB and connects to the other plastic pieces. The board simply slides into the 3D printed piece, and that's basically it. Let's move the mainboard aside for now and grab 2 tracking cameras. These 2 cameras will be used for the inside-out tracking and will be mounted directly on the controller. I've also prepared a small plastic bracket which will hold both cameras in the correct position and angle and will be used to mount them on the controller. The cameras basically snap into the plastic piece, which will hold them tightly. It's a very simple solution, but it's very precise and has proper angles and distance for the slam tracking. Of course, I will use 2 self-tapping screws to attach it to the main piece. It does look pretty good so far, and there's quite a lot of space for any future add-ons. Now let's install the trigger. The trigger will use this plastic bracket as well as one tact switch. Tact switch will be mounted directly on the plastic bracket using two self-tapping screws. In the future versions, the trigger will be swapped for way better analog trigger, similar to those in other VR controllers. After installing the tact switch, the trigger assembly can now be installed directly on the main plastic piece. The whole controller is designed to be as modular as possible in order to see what works and what doesn't. If I decide that one of the components just doesn't feel right, I can easily remove it and replace it with improved version. And finally, when me and my team decide that the controller is working perfectly and all of the parts feel right, then I will make whole design more streamlined and user-friendly. At this point in development, most stuff like finger tracking and SLAM are not ready to show yet, but they're coming and I will most likely feature them in the future videos. Now let's add the trigger button. For this part, I will use a piece of filament which will work as a hinge and will attach the actual button to the tact switch assembly. The whole thing is pretty simple. I've basically attached two plastic pieces together and secured them with the filament piece. The button moves freely and the tact switch can be easily pressed. This piece here is the battery cell cradle. It will be used to hold the battery and I will also mount a couple of other boards on top of it. First I will install the battery connectors. Those simply slide into the plastic piece, which is pretty tight, so there is basically zero chance for them falling out. Of course it's possible to use any different kind of battery, but I wanted something replaceable for the Devkit. The other PCBs, which I've mentioned earlier, will be simply mounted using double-sided tape. The first PCB is the charger board. This is pretty common, TP4056. And the second board is the radio. This is the NRF24L01. The radio PCB will go to the slot on the side and the charger board will go on the top. But first I will have to install the power wires. The power wires will connect directly to those two pins right here. The wiring may not be super pretty, but I will most likely make a custom board for it. As for the battery, I will be using this 3.7 volt battery cell, which is the exact same size as AA battery. The charger board uses USB Type-C cable, but it only works with the 2.0 version. This will definitely have to be changed for the future iterations. The battery cradle is meant to be mounted directly to the main PCB housing. It uses a single M3 screw, which makes it possible to adjust the battery cradle angle. And now let's connect the radio chip directly to the main PCB. For these connections, I will use short Kynar wires, which are perfect for prototyping. It took me a while to solder all of the wires, but the radio chip should now be working. Of course, I will also have to connect the battery wires directly to the main PCB in order for it to get power. I've used Kynar wires for the power as well, which may not be ideal, but I think it should work fine. And in the meantime, I've discovered that the status LED may actually be broken, so I've replaced it with a regular SMD LED. And as you can see, everything is working fine now. The LED is not blinking anymore, which means that the radio chip is connected properly. And now I will have to backtrack a little and remove the trigger hinge. This is because I actually need to connect the tact switch button to the main PCB. After connecting the tact switch button, I can now reassemble the trigger. And now I can finally install the faceplate cover. This is the piece that holds the faceplate buttons and closes the whole design. And of course it uses self-tapping screws. I must say, the whole thing looks pretty good so far and it's actually pretty comfortable. And it's quite smaller than I thought it would be. But to add slightly more comfort, I plan to add two plastic bumpers, one for each side of the battery cradle. This will make the handle feel more natural, which is very important for longer periods of use. The bumpers are pretty simple, since those are basically two stripes bent at an angle. The left one will go right here and will be secured with self-tapping screws. And the right one will go here. The bumpers don't look like much, but they actually provide quite a lot of comfort. For the PC receiver, I will use a Arduino Pro Micro with Arduino Nano connected to the voltage pins, which will work as a voltage regulator for the radio chip. And as you can see, the Steam VR successfully recognized the controller. Right now only couple of buttons are working, since I'm still waiting for the proper firmware. Right now I'm using Hades VR, which is pretty excellent on its own, but the finished product will use a brand new Steam VR driver. And that's pretty much all for today. I'm still actively working on this controller, and the later versions will feature way more things, like proper finger tracking, SLAM tracker drivers, improved battery mounting, custom PCB for the charger and maybe radio, fixed status LED, and a way better joystick. Thanks for watching everyone, and hope to see you in the next video. And as always, huge thanks to my patrons. See you later and goodbye.